So hi guys, I'm Rishi. I'm a master's student at ISI Kolkata, and today I will be taking this tutorial session where I will be talking about how to like approach any machine learning problem, but it will be mostly focused towards like the task of the Datathon this year, that is intent classification. So yeah, I participated in IndoML Datathon past year. I was within the top teams who were selected to attend the IndoML conference itself. So let's get started. So this is a brief intro to what I do and what are my interests. So you can like anytime reach me over LinkedIn if you want to talk more about something you are working on. Okay. Good. So, what we will cover today is like we will see some techniques and the importance of exploratory data analysis on the unstructured data, and like then we will talk about baseline, like how to like set up baselines to compare and improve on them, and then how is a general approach to like improving a solution. And I will give you some pretty good ideas to like get started. And this baselining is the most laborious part and the major chunk of the work. It like involves data preprocessing, training and inferencing, and evaluating results. And once you have this pipeline ready, you can like keep on improving each portions of this entire pipeline to like continue to get better and better results. So let's dig in. So let's get started with the exploratory data analysis. So like a good exploratory data analysis is the key to the success. Like, why do we say that? Because in this modern AI world, so there is this lots of unstructured data and like these patterns and the like the summarization of the data gives us various insights to what might be present, what can be used or leveraged to like design a solution. So a good exploratory data analysis can like unlock some hidden insights to the data. Like you can see some patterns in the embeddings, or maybe say some words pop up more in some classes and so on. So I will talk about some techniques like what to look out for while doing exploratory data analysis. So one of them is like in the intent classification task, the first thing you should be doing is like try to understand what are the class labels present to you. So you can do one thing, that is count the class labels which are present in the training and in the training data set. And there you can see whether there is some skewness, whether like all the classes are properly represented or not. Because this machine learning models, if they are given skewed data or just data of one kind to be more, then they don't actually learn this decision boundaries between the classes pretty good. So that should be one of the things you should definitely try out as a part of your EDA. And then you can also do something that is like try to embed those sentences and then do some dimension reduction technique and see whether what sort of clusters you are getting based on the labels. So here, what you see is like a cluster. This is from my Datathon challenge. There were some 16 classes of scanned documents. So I plotted the t-SNE of them based on some ResNet and efficient net embeddings. So you can see like it will give you some insights of how good the separability is, and whether like what sort of thing you need after you use those pre-trained models. Now, after like you have some good idea about the nature of the data set, you can also try out like finding some like handcrafting something like whether some words appear more in one class or a different set of words appear in different class. This here what you see is like here all the washing sort of things are clubbed together in the word cloud of that class. Like in the text of that class, what sort of words are more frequent, and a different class which involves drying sort of thing. There you can see that in the text, the drying sort of words are clubbed together. So based on this counts, you can see that the counts might be a good idea to start proceeding to like build a basic model. Like the traditional models, they use frequency based approaches. So these are like some of the techniques you can use for exploratory data analysis. There are plenty more. The more you do it, the more you will see like interesting things popping up. So next, we will move to an important step, which is the baselining. Baselining refers to like you create a basic solution, like complete. Like you start with the data set, then you pre-process it, then you like build a basic model on it, and then evaluate it. So once you do this entire end-to-end thing with a simple solution, you can now understand that you can iterate over each of these parts individually and improve your final solution. So this is very important. Machine learning is an iterative process. So we will start first with like data pre-processing. So it involves data cleaning. Like these machine learning models are definitely not robust to noise. There have been various works, even a work I did this summer, which like showed that the model's performance drops by leaps and bounds if you don't have a clean data set. So definitely, one thing to do is to clean the data so that the predictions of the model are reliable. And then the next step would be to find a suitable representation for the data. Now, obviously, you can't feed in words to a machine learning model. Like it can be anything from trees or say SVMs and neural nets, anything. You cannot feed just raw words to it. You need to have some sort of numerical representation of the unstructured data. In this case, which is text. So we want to find out a suitable representation of the data so that you don't lose much on the differentiating features. Like the differentiating features means the features which will be useful for you to help the model classify between these classes. Because if you choose a representation, like say simply counting the words, that might be a good approach, but may not contain enough of a differentiating power. Like between subtle intents, it might fail to distinguish between them. So this is very important to choose a good data representation, which has dense and differentiating features. So the first thing is to make the data consistent. So it goes for any classic NLP task. Just do we need stopwords or not? Do we need the negation? Like no, not should it be removed? Or we need to do lemmatization, tokenization. These things are standard. You can check out various blogs available, especially the NLTK package that provides various functions to do this sort of tasks. And here you can see that you can also try adding POS tagging, named entity recognition, to add some more differentiating features. Like the model should focus more on those words or tokens. And the next step, this is a snap from one of my works which I did during a project. So here you can see that here commas are I removed the commas as a part of making the entire data set consistent. I replaced them with and then somewhere there were slashes. So the model which I was using, that wasn't good at handling slashes. So I replace that with or, and there you can see like various variations of 4 inch and 6 years and 12. So these are converted to standard forms. So these things you will only gain insight if you look into the data. If you look at what's the nature of the data, what do the plus signify here? Like here in this case, these were titles of a product. So here plus means a different thing compared to some other case. So these things you need to watch out for. And after the data cleaning is done, the next important step is to have the text representation. So text representation can be of various forms. Like you can use bag of word representation, TF-IDF. If you want a very brief intro to it, it's like bag of word just signifies that counting whether a particular word appeared in a sentence and how many times. And based on this count, you create a vector for that sentence or text, and you use this vector for your further post processing in the model. And TF-IDF is a very similar thing, which uses the same frequency-based approach to find out the significance of a word in a corpus. Corpus means your text data set, you can say in simple language. And these techniques on the right side, which you see, are the classical techniques. They rely on word frequencies mostly. And the pro of them is like they run fast. Sorry, this has interchanged. The con is that they are non-contextual, and the pro is that they are very fast. And the thing for dense embeddings, which are the neural embeddings like doc to vec or word to vec, or there are now various other models. I will talk about them a little while. So there they produce very high quality embeddings, keeping the context of the words and the arrangement of the words intact. But the con is like they are slow. So if you want to build a quick solution to like try out how it's working on the data set, then you can try these classical techniques to start with. Then you can move ahead with like replacing the vectors with the dense embeddings from neural methods. So let's move ahead. So the next part of the baselining is to like training and inferencing. So like here, the first thing to do is like you have to have a mindset of what sort of models you want to go ahead with. So there can you can try to go ahead with traditional ML models like trees, SVMs, and so on, or you can go with neural models, which are like quite popular and to be honest, they perform significantly better than their traditional ML counterpart, mostly because they keep intact the context of the sentence together. And there have been massive development, and these models are available everywhere right now. I'll talk about some sources and some models you can use. And after you have shortlisted like some of the models which you want to try on your data set, just go ahead and like create all the data pre-processing needed for that model. Each model requires a different sort of pre-processing. Sometimes the authors of those models provide these pre-processing functions, making life for you a little easy. Otherwise, you have to do some little bit labor to like do the exact pre-processing needed for that model. And some pre-trained models could be a very good idea. Like you can start with some language models, some that will produce some text embeddings. Popular ones available is Google Spurt, then there is Roberta Experts. Now these models tend to be larger. So if you face difficulty in running these models on your local machine, either you can try a machine with a GPU or Google Colab, or like you can do one thing that you can try out smaller variants of this model. And all these models are readily available in Hugging Face and other places like PyTorch models and stuff like that. So you can definitely pick this out from there and go ahead with like fine tuning and training it on your own data set. So the thing we need to do is to like pick up these models, uh, pick the necessary pre-processing steps, and then try to train the model. Now, this training step can be like continued for as long as we don't see like the losses to be flattening, or you can do some 100 steps or 50 steps as to see like how good the model is performing, and then you can go ahead and like make some changes and train again. And it's a very good idea to like have a training set and validation set. So what you can do is you have a massive data set containing lots of intents and lots of text to be classified. So you can randomly split it into a test set and training set. Sorry, validation set and training set, and you can go ahead and train the model. And after each step, you can like do some validation and do some find out the training loss. So that can be a way to track the model. And one thing is to like now after you have a model trained, it is very important to understand what mistakes your model is making, how the model is working. So there are these things available to you. These are called saliency maps. So you can use like gradients, L2 norm, or like the grad of the input with respect to the input, or there is something called lime or sharp values. You can use them to like find out which tokens of the text the model is paying more attention to while making a particular classification. So if you see that a bad intent has been classified, but with the use of like keywords like great, good, so that might be a little suspect. Like you can suspect a little bit that something might be going wrong. So you need to dig deeper in that case and try to like understand what's happening, whether the labels you have put is like, are they wrongly, like, are they shuffled somehow, or there have been some issue. So this is a great thing to like do to check how the model is performing. And next we will move ahead with like evaluation of the model. Now, whatever you do till now is like you have qualitatively seen the model's output, model's performance, everything. But somehow you need to make a evaluation metric which will like show to you what's happening. So evaluation metric should have been provided, is provided with you by the Datathon itself. And you can also take a look at misclassification and things like that. So evaluation helps you compare between various baselines you have. So like if you are testing three baseline models, so you can compare between them and which one is working good and why. And then a good thing to do is to always look into the misclassification a model is making. So like mistakes which your model is performing, you can like understand what's the nature of this mistakes and how like you can come up with a better idea which is generalizable and which is like more making the model more robust. So, and once you reach this step of baselining, you will have the entire pipeline ready behind you. You have already done data pre-processing, you have already done the model training, and you already have written the evaluation code. So now all you need is to like improve on each of the step. Like say someday you find out that this new model generates better pre-trained representation of the data. So you just swap in that part, do the rest of the job, and then evaluate it. Then you find out that you can do much better than a existing uh, fine-tuning network you're using. Then you can swap it out and you can evaluate it again. And this is how like the iterations in machine learning goes on. So a good thing you can do is like make a confusion matrix, look into this codes of like what are the misclassifications the model is performing, and dig into them, see what's happening, why it's like, is it because like the data set itself is very noisy? Is that the reason, or whether you can do much better? So these are the things you should definitely try picking up while doing this part of the work. Now, now comes the like most interesting part, the part which like makes most of us so excited about machine learning is to like have your own impact, like try to fix the model's weaknesses, try to put in some clever ideas, tricks. So like one thing which I just said on the previous slide, that is you look into misclassifications. Now, suppose you find out that the misclassification is between some very subtle difference in the classes. So you find out that these keywords, like say the good keyword, that appears only in one of those classes but not the other. So that can be a good way to like give your model some extra discriminating power. So this sort of tricks, the sort of things you should always try to look at, like what keywords are appearing in what class and so on. So one thing more which you can do is like have better data representation. Like someday you find out that um, one of the models, another pre-trained models, they are providing better features, which are more like differentiating and so on. So we can use that for having a better data representation. And then one more thing we can do is obviously this part is like maybe the most discussed in literature, that is having a better model or using some sort of data augmentation. Now, having a better model, this can include various things like having a better architecture, having a better training loss, or in data augmentation, you can like try adding some noise to the data so that the model itself gets resilient, try to understand like this sort of noise appears and so on. So here I will discuss some ideas. One of them is to have a better model, which I just said. Like suppose you are using a feed-forward network at the end of some uh, pre-trained model to like do the classification. So you might see that a transformer network is performing better. So these are all the experiments you need to do. Like once you have a baseline ready, you need to be ready to swap things and see how it's like working. So suppose at the first baseline you used feed forward network. So in the next iteration, you will like try to see whether a sophisticated network of like say transformer networks are working good or not, or whether you can do use a convolution sort of thing or LSTM sort of thing. So that can be a better idea. So this deals with better models. So you can also go ahead with using better losses. So now one standard loss which is used like everywhere in the literature in multi-class classification is like use softmax loss. So one thing which you might do is like pushing the model harder to be more confident on what's classification is doing. So you can add a margin, and the model will try like harder to find the like make the separation between the embeddings more farther away to have a better classification. Or you can go ahead with generating synthetic data. Like say if you did the class, like counting the number of instances for each class, and you found out that the one of the intents is very poorly represented, and you suspect that that might be a reason your model isn't doing very good on those sort of intents. So you can do is you can generate synthetic data, like generate synthetic sentences based on the intents. So there are various works going on in this direction. Like they use large language models and things like that. So if you have like the interest to like do code attack the problem in that direction, you can definitely go ahead and try it out. By the way, this thing which you see here, this is the linguist recent paper which proposes intent like generating data synthetically for intent classification tasks. And next is like this sort of deals with the data representation, improving the data representation. So uh, one thing can be that each model is picking up some features or the some discriminating factor better than the other models. So why not use all the models together? So this can be a good way. It will give you multiple views of the same text data, and you can maybe have some majority vote at the end ensemble approach to like classify the intents at the end. So this can also be a very interesting idea. A very similar idea is something I worked at Uni for during my internship, and I will like try to like give you some novel ideas maybe which might be interesting for you to try out as a solution for the challenge. So uh, like it always, it's not necessary that you need to have a very high score in the leaderboard. Having a novel approach and a decent and good score is like a very solid combo. You can like, you should always be in the outlook for a generalizable solution which might not have been tried before, or even if it has been tried before, you are doing it somewhat differently, which makes your approach better. So don't reinvent the wheel. So like definitely there are so many things you can do, and so much of work has already been done. So definitely make use of all the resources available. Go through literatures, go through past literatures, connect some dots from the past literatures. Like say a past paper had some intent classification model, and they didn't use some better embeddings. So you can go ahead and swap that with a better embedding and see how their model is performing. Or you can see that if they are facing issue with some sort of subtle classification, which is now solved because of, say, clustering or something. So that can be a good idea to go ahead. So some of the interesting ideas which came to my mind while looking at the problem and working on it is like clustering. This is a very good idea to do, like how the data set clusters, what are the natures of the text or the embeddings which make them cluster together. Can you improve on this clustering sort of thing? So this can be a good idea to go ahead with. Large language models, like the buzz of today's world, like if you can somehow use them to generate synthetic data or use their in context learning capabilities to like classify right on spot with some few shots something. So that can also be a very interesting thing to look at. And another thing is like since intents are many times they are lying within a smaller subset, which is again lying on a superset and something of that sort, like in a hierarchical sort of fashion. So there maybe you can do a thing for like a hierarchical classification sort of thing. where at each level you will classify, and then you will see if you can classify further down that level and so on. So this will like give you a model of better discriminating power. So these are some of the approaches. These are all widely used, and you can definitely find some blogs and things like that. So this is something you should definitely try to implement in your solution. And so that is like the end of my presentation. I will give you a brief tutorial on how to implement this in Python. A very basic if you are very new to this area, like what I was back in my time. So you can pick up some pace and start working on the problem. Okay, so I will proceed with the tutorial on the notebook. Just a second, I'm sharing my screen. Can someone let me know if my screen is visible or not?
Yeah, it is visible, but it would be better if you zoom in.
Okay, okay, I will zoom. Between, did you guys have any sort of problem or questions which you want to discuss? Some ideas I can help you with that from the talk I gave, or something which you're trying. Let me know if the screen is now clearly visible to you.
It's visible, but I think the font can be a bit bigger at the code portions. If it's
Okay,
the,
okay, I will make it bigger. Is it big enough?
yes, for me, yes.
Okay. Okay. Let me know if you face any difficulty in looking. So here I will I can't solve the exact problem which you are given in your datathon. So I just picked up a binary classification of sentences, and I will show you uh, basically how to approach the problem, what sort of things you should do, and what sort of libraries are available to you. So here I use in this notebook TensorFlow. If you are comfortable with PyTorch, go ahead with it. So, so importing some basic libraries, TensorFlow for the model building purpose, and scikit-learn has various metrics like F1 score, precision, and recall score, and NumPy is for general matrix things. So now the data is a very small dummy data set. This is these are the four sentences. You won $1 billion, great work, and send me your bank account information. So these are now marked as 1101. So this is a fabricated data set. You can think of it like maybe a spam classification or something of that sort. So this is your data set, the sentences, labels, and then what we do, will go ahead and do is after we have this data set, we will have to prepare the data. So how do we prepare the data? You need to decide on the embedding dimensions you want to use, the maximum length of truncation, because these I will be using a neural model. So the model needs to be fed a matrix. So now if the sentences are of various length, so containing various number of tokens, it will create a issue with the model. So I need a max length. So I'm allowing 10, maximum length of the sentences allowed is 10. If anything is bigger than that, either I can throw it out or I can truncate it. And the vocabulary size basically deals with what are the tokens you will allow, what's the maximum size of the vocabulary. It's 10,000 in our case. And the last token would be assigned to the CLS token. CLS token is also referred to as classification token. It summarizes all the info of the entire sentence at once. So now the model, if you are aware with it, there is something known as transformers. So these transformer models are these transformer models, they require these sort of classification tokens they generated. So that is particular to that model. So the first thing we will do is prepare the data. So the preparation step involves here I am using the Keras preprocessing tokenizer. and I have a vocab size of 1,000 or 10,000. So there will be like in total 0 to 9,999 tokens. So I will pass that to the tokenizer, and the last token is reserved for the classification. And once it's like you have like created this tokenizer class, you can fit on the text documents you have, like on the sentences. So once you have fit on sentences, now your sentences, like these sentences, will have split into tokens, and they all have been assigned some IDs. Like say if U is assigned the ID one, one is assigned ID two. So this sentence will look something of the one comma two comma three and so on. So this is like you fit the tokenizer, and then you convert it into sequences like IDs. You add the classification token, and then you pad the sequences if they are a smaller length, or you truncate it if they are of longer length, and you convert that into a tensor, and you have your training data ready. So this is the data cleaning part, which we like discussed in the slide. Now the task is to build a model. So this part, most likely you don't have to do it on your own. So I will like zoom it out a little bit. So this part, most likely you don't have to do it on your own. This is like the implementation of the vanilla transformer. You can pick up any model from Hugging Face and use it. I will give you a small like idea of how to do that, not from Hugging Face, but from PyTorch Zoo. Sorry, TensorFlow Zoo. And this is our model. Like you don't have to worry about the exact architecture. You can use any previously used architecture. I will show you how. So this is our model. It takes an input, it passes it through an encoder. So now your sentences are encoded. Encoded means they have got their numerical representation. Now, after that numerical representation, once numerical representation is created, you take out the classification token, you pass it through a dropout layer, dense layer. Dense means feed forward layer, and then again pass it through dropout, dense. Now with these dense layers, you can use like ReLU activation or sigmoid activation or anything. Now here is like the model summary. You can see like since we specified the maximum length of the text to be 10, it is in the input layer, it is 10. Now the 10 is being projected after being encoded to 100 dimensions. And now the 100 dimensions, we take the last vector of 100 dimensions. We pass it through these further layers, contains 32 neurons, and then two neurons at the final layer, which signifies the first neuron will signify like whether it belongs to the first class, and the second neuron will signify whether it belongs to the second class. So now you compile the model. Now this is like sort of TensorFlow specific. If you use PyTorch, you don't need a compile step. You need to specify the optimizer. Here we are using the Atom optimizer. The loss is like the sparse categorical cross entropy. You can use other sort of loss. Yeah, if you are wanting to use some custom losses, like the one I showed you, like softmax with a margin, you need to write the loss function class separately. And the metric I'm monitoring here is accuracy. In PyTorch, also a similar counterparts are available. And now we just fit the model. We have the training data, we have the labels, we supply the batch size and the number of epochs, and it will be like trained. This was a dummy data set, so I just trained it for 10 epochs. And you can see like the accuracy increased slightly. Not a very good example to like demonstrate the point, but I will show you another like notebook. So now after you have the model trained, you can like you predict on the training data set the class probabilities. So now our final layer had two neurons, right? So like this is the first neuron's output, this is the second neuron's output. So what you can see is here all the classifications are done as one. Like this is the greater than 50% accuracy. So we will choose like this one. If you have multiple classes, you will choose the maximum out of those scores maybe as a output. And like what we'll do is like to figure out which one of them is like the high score, we'll just use the argmax function on the axis minus one, and then we'll get the predicted labels as 1 1 1 1, as I said, like 1 1 1 1. So now you can use the scikit-learn's precision score, recall score, and F1 score function, pass in the labels, the ground truth labels and the predicted labels which you have got, and you will get the score of your model. So this is like the evaluation. Now here what you see is here we have designed the end-to-end model, like starting from the data pre-processing to evaluation. Now if you feel any of this part is working, like you can do better, you will go to that part, make changes only to that part, local to that part, and then carry on. Now, one good thing of the doing baselining is you can figure out good values of hyperparameters, like what should be the batch size, and then what sort of how many layers, fine-tuning layers are working good for you, and so on. So task two is nothing; it's just increasing the number of heads to a larger number. So I will give you an idea of what I did during my time during the Datathon. So it was a image classification task, but like concepts remain very similar, identical. So here we take into account the libraries like Matplotlib for plotting, TensorFlow. At the time, I knew only TensorFlow. It was beginner friendly. It was easier, but PyTorch might be easier for you also. So we load the data. So the data is given as the image paths and the labels. Here you can see like it's a multi-class classification. Just the one like you have, 1 to 16 other classes, and these are the images. Now, what we will do is we will, these are the names of the classes like letter, form, email, and so on. And one thing which I was saying in the part of EDA was to have a value count of what are the number of instances in each of the like class label. So here you can see like it's a very well balanced data set. All classes are adequately represented. So might be we can expect that the model won't be facing any issues due to this class imbalance. Now, this sort of thing you need to do. Like you need to check out examples, instances from each of the labels. So here you can see that I have visualized 4 instances from the letter, 4 instances from the form, and so on. So these are something. And then this is like a basic data overview. Like now, after we have done this sort of data overview, we can go ahead with like trying to fit our build our model on it. So after the data overview is done, we can start preparing the data. So this part might be different for you because you will be working with text data, but it won't be much different. Different in the sense that you will be using padding like max length, tokenization, limitation, these sort of things. Here I have used different sort of like image specific data preparation techniques. So I won't be discussing them. If you're interested, you can check it out later. I'll give you the link to this. And then after you have like all the data pre-processing done, I have designed a data generator. Data generator is something which you will call and it will continuously start feeding you data. In PyTorch, it is called data loaders. So using a data loader, you can like continuously fetch data and its corresponding label and pass it down to your model, train it, again call it, fetch more data, and so on. So it handles all the heavy lifting required to like load the data from your CSV files and passing it to your model and like doing some pre-processing step necessary. So here you can see like my input image tensor is like 32 is the batch size, 800 is height, width, and 3 is the channels. For your case, it will be like something of this 32, and then there will be 1000 say, which is your length of the maximum, like length of the sentence you're accepting. And at the last layer, maybe you can have the embeddings if you have already prepared the data in the embedding forms. So now this is the pre-processed data set I had. So now we will go ahead with like building the model. So here this is a very basic model. It just uses like convolution layers, batch normalization layers activation to design this layer. And you can see that it's like there are various layers. It's just the ResNet model I recreated, and then you compile it again to then again you can design some callbacks which will keep track of whether your model evaluation the evaluation metrics on the test data set is dropping or not, and if consistently for 3 epochs if it's increasing then you should stop your training. You can whether check what's going on and so on. So you can design these callbacks. These are readily available, and now you can just see that after some training, the train loss has decreased and the training accuracy has increased. Now, obviously, the training accuracy is bounded between 0 to 1. So this is like sort of, I guess, 70% or so on. So this, and now after we have the model trained, we can like predict using the same predict function. We'll predict now after using max, finding out the maximum score of each like instance. We can do this sort of got this sort of labels. Now you can see that the matches, how many labels match with their corresponding ground truth label is 4671. And here I have loaded. Now this was the task for the training dataset. Now I also had a validation dataset. So I loaded the validation dataset, which contains only, sorry, it is a test dataset. It contains only the images. So I load them. I create the same data generated for it. I predict using the model on the on the test dataset, and then you get some labels, and this is the submission. So now, during my time, the datathon was happening on Kaggle, so we had to submit it in this sort of format. So it will be might be different or same for your case also. So these are this is the basic model. Now I can show you some more things. I will share a link or two. Those are my repos. You can check it out if they help you out. I'll stop the screen sharing, and you can, in the meanwhile, if you have any questions to ask to me, you can go ahead with it.
Thanks, Rishi. Let's see. Let's wait for some questions. So let's see who posts
Yeah.
them. So Rishi, I have a quick question. So in your slides, you have mentioned about this data augmentation for indents, and you have mentioned about some
Hmm.
specific paper. Can you show me which was that paper?
Yeah. I will show you.
Yeah.
So I guess this was the one.
Mhm.
So this one, right? So this
Yeah.
is a linguist paper.
I
This
see.
is the linguist paper. It's from Amazon, and
Mhm.
they have like created, like we can put in this one star, which means
Uh-huh.
one means the city, two means the time range, three means the state, and in this way we can design what sort of
Yeah.
intents we want to make. Yeah.
So is there a paper link that you are aware of?
Paper link means this linguist paper.
Yeah, yeah,
Yeah, it's like available.
yeah.
Yeah, this is the paper. I'll share it on the uh, Q&A maybe.
Sure.
So this is the linguist paper, and I will share some of my repos, which
Sure.
like the participants might find useful.
Okay. Uh-huh. Nice. Okay.
And this is my IndoML 22 Datathon challenge. If you find it useful, like how to approach, how to maybe write your report if that is asked this time, and you can go ahead with like looking at these repos and so on. And like if you later, while trying to approach the problem, trying to brainstorm the solution, if you find like any problem, you can definitely reach out to me on LinkedIn, and I will be like happy to help.
So
So
Rishi, the
if you
database,
guys, yeah,
the linguist paper that you mentioned, so did you try some of those while at Unifor, or was it something different that you tried there?
Yeah, it was something I tried during like my internship at Unifor. Yeah.
I see. That's nice. So yeah, so let's see if there are more questions. Pratham, if you're talking about the surprise data set, yes, we will release some sample data by next week or next Sunday. And then we will have the blind test data released on the due date. The due date, I think, is October, right? So, so you will get another 10 days to use your test data, but without labels. But labeled instances, you will get some for each class. You will get something like 5 to 10 for each class. I assume that's the question you wanted to ask. Right, Pradhan? Is it the surprise data set that you're talking about? Yeah, thanks. Yeah.
Like one quick suggestion would be
I
to
have a
like
question
while
actually.
yeah,
Hello.
go ahead. Yeah. Yeah, go ahead.
So you just now showed us how to handle multi-class problem, right? So
Hmm.
what if in the
Hmm.
same sentence you have the two different intents, for example? How will you handle that?
Yeah, I just discussed with the organizers about whether that's the case or not for the current uh, challenge which is given. So it is like for that current challenge, it is not the case. Each one has a like single intent, but the problem which we're talking about is also well approached in the literature. Here you will have like two neurons or separate neurons, and you will have them like predict simultaneously two classes. So like you can do that. Like one quick example for that would be like say you have some uh, chunking task where you have a sentence and you need to find out what's the starting and ending of a noun phrase. So here the starting is particularly different. It's a different pointer, and ending is a different pointer. Both are simultaneously predicted on the same sentence. So this sort of models are available. You can modify the multi-class, whether instead of using a softmax, you can do some other things there at the end, which will do make that work.
Okay, thanks for
Yeah.
So I believe that's the scenario of multi-labels classification, where I think the active action function typically changes, right? Is that what it is typically?
Yeah. Yeah, like the softmax, it normalizes the entire final layer output, the scores, but we don't need that in that case because we have multiple labels available. So we will change that.
Thanks, Rishi. Dave, can you clarify a little bit more on the scenarios? I believe it. Yeah. So can you clarify it? I'm not sure if I fully get what you're saying. I mean, if you can unmute and probably mention, that will be best.
Hey, am I audible?
Yeah. Yeah.
Yeah, you're audible.
So actually, my question was that there are only 3 to 4 intents per scenario, compared to a total of 60 intent labels. So if someone is given a scenario, it becomes comparatively easier to predict the intent. So that raises the question, will scenario be given as a feature in the training data set, or is it something that is actually a label and we
What
have
is
to
a
classify it?
scenario? I don't know what is a scenario. Can you
So
clarify?
for example, an alarm is a scenario, and
I
within
see.
alarm, there
So
might
you're
be 4
talking
different
about
intents.
you're talking about a what do you say? You're talking about a field in the data provided to you, right?
Yes, yes.
Okay, so I think Pratham, I think I got your question as wrong as well. So first of all, that is something which we generally don't expect to be part of the input or a feature, as you mentioned, right? So for the new data that we provide, we will not have anything related to scenario. We will only have a turn, because if you think about from the so if you look at the current data set, it is basically used for Alexa. Do you think that the scenario is available to a system? If it is not available to a system, then why should we model that scenario, that use case, right? So if Alexa had a button like alarm or a separate button for each scenario, we would have, where a user is supposed to press and then say a command, we would have thought of that scenario. But Alexa is supposed to be completely touch free, it's only speech, right? So
Yeah, one interesting thing which you can do maybe if scenario is available to you in the training data set, then maybe you can try predicting the scenario if that is more easier. And then once you have detected the scenario, you have some 3 to 4 intents going on within them, then you can do that detection at a second level, like a hierarchical classification. But in your test data set, neither the scenario will be available to you or neither the intents. So you have to detect the scenario, which you have already trained a model, and then further in the second level, you have to detect the intent. So that can be approach. Yeah, it's a good approach.
that's actually an excellent suggestion. Only thing is that, yeah, for the new surprise data set, we may not have it, but that's something that
Yeah, like
the
in the
scenario
training
information
data
is,
set, if that's a way. Yeah.
no, yeah. So what I was saying was that we can, what Rishi is suggesting is actually an excellent idea, because we can use that information in massive data set to make a better model out of it. But for the surprise data set, which of course you will not train from scratch, you will adapt it, right? For that, the scenario information might not be available. But it's an excellent way
Thank
to.
you very much. Yeah, that was the. Yeah.
Thanks. Pierre.
I believe those are all the questions I have, I guess.
Yeah. So, any more questions or? So let's thank the speaker. So thanks, Rishi. That was really a great session, and there were some cool ideas that we discussed. So yeah,
Yeah.
that's really good. So let's all thank the speaker, and yeah, thank the speaker for the session.
All the best, guys. Good luck. Try out all your crazy thoughts you have about the dataset, about try to learn as much as possible from the Datathon. It might just give you a head start to like in a machine learning research career or some applied field.
Thanks, Rishi. Bye. So let's try to connect. So we will probably have the next talk in the series next week, or the coming weeks. And thanks a lot, Rishi, for your time.
Yeah, thank you.
Bye.
Bye bye, guys.
Thanks a lot, Rishi.